Stop scrolling because some of these technologies are already operating in plain sight. What if the future didn't arrive loudly, but quietly slipped into train stations, sidewalks, and even manholes without anyone noticing? These systems are not science fiction, and that's the unsettling part. From machines that predict human movement to roads that repair themselves, Japan is testing realities most countries haven't even imagined yet. And what you're about to see raises one question: how much of the future is already controlling your world? Robotic, rest mode, convenience stores. At the bottom of the list, but still quietly revolutionary, are fully or semi-autonomous convenience store systems being tested in Japan, especially in late-night urban zones. These stores shift into a rest mode, where most human staff are replaced by automated cleaning units, robotic shelf scanners, and AI-driven inventory systems. Instead of shutting down, the store continues operating with minimal oversight, tracking stock levels in real time and alerting remote workers only when necessary. Some systems even handle automated checkout corrections if customers make mistakes. The unsettling part is how normal it feels. Customers still walk in, buy food, and leave, while machines silently manage everything around them. It raises a subtle question about the future of retail labor, not whether humans will be replaced, but how long it will take before replacement feels completely invisible. AI street crowd sculpting systems. In heavily crowded districts like Shibuya, experimental systems are being developed to manage pedestrian flow using AI-driven timing adjustments in traffic lights, signage, and crossing intervals. Instead of reacting to congestion, these systems predict it seconds in advance and shape how people move through intersections like invisible architecture. Cameras analyze density, walking speed, and direction, then coordinate signals to redistribute movement across nearby streets. The unsettling implication is control without awareness. People think they are freely navigating, but subtle timing changes guide them away from bottlenecks. During peak hours, the system behaves almost like a conductor directing a human orchestra. It doesn't stop crowds, it reshapes them continuously. What makes it even more fascinating is that pedestrians rarely notice it happening at all, even though their movement patterns are constantly being optimized in real time by invisible algorithms. Modular floating urban platforms. Japan's coastline experiments include floating urban modules designed like interlocking blocks that can be rearranged depending on need. Developed in part through maritime engineering research, these platforms can function as housing units, emergency shelters, commercial zones, or green parks. The design allows entire communities to adapt to rising sea levels or disaster displacement without rebuilding from scratch. Each module connects through flexible hydraulic systems that stabilize movement while still allowing repositioning. What makes this technology unusual is its philosophical shift. Cities are no longer fixed land structures but movable systems. In theory, the entire districts could be reconfigured overnight depending on economic demand or environmental threats. Though still largely experimental, these floating structures represent a future where geography is no longer permanent, and urban life becomes something that can drift, reshape, and reorganize like a living mechanical ecosystem. Predictive disaster signage systems. Across Japan, digital signage is evolving beyond simple alerts into predictive communication systems tied to seismic and weather modeling networks. Instead of waiting for earthquakes or typhoons to hit, these signs begin changing their messaging moments before impact based on probability algorithms. Train stations, highways, and public squares can display escalating warnings that adjust in real time as conditions develop. What makes this system unusual is its psychological design. It doesn't just inform, it prepares behavior. Messages subtly shift tone, urgency, and instructions depending on crowd density and location vulnerability. In some trials, signage even recommends evacuation routes dynamically based on congestion predictions. The unsettling part is how calm it remains while delivering potentially life-saving urgency. People walk past changing warnings without always realizing that they are being guided through a live predictive disaster model that updates faster than human reaction time. Robotic hospital supply walls. Inside advanced Japanese hospitals, experimental infrastructure allows entire walls to function as automated supply systems. Instead of nurses manually retrieving medicine or tools, staff can scan badges that trigger compartments within the wall to open instantly, delivering precisely requested items. The system is connected to hospital inventory databases, ensuring real-time tracking of every surgical instrument and medication dose. Some versions include robotic arms hidden behind panels that restock compartments without interrupting operations. What makes this technology remarkable is its invisibility. Patients see only a clean wall, while behind it exists a fully automated logistics network. It reduces movement time, minimizes errors, and allows medical staff to focus entirely on patients. However, it also represents a shift where healthcare environments become responsive architecture, adapting to human needs in real time like a living machine. Underground heat harvesting grids. Beneath Tokyo and other dense cities, subway tunnels and underground shopping complexes generate enormous amounts of wasted heat. Japan has begun experimenting with systems that capture this thermal energy and redirect it into district heating networks for nearby buildings. Pipes and heat exchangers extract excess warmth from infrastructure that would otherwise dissipate into the ground. The system turns transportation networks into hidden energy sources, effectively transforming cities into layered power ecosystems. What makes it unusual is its invisibility. Residents may never realize their heating system is partially powered by commuters and trains moving beneath them. This creates a new kind of urban metabolism where human movement becomes energy. The concept challenges traditional ideas of waste, showing that even crowded underground spaces can become productive contributors to sustainability without changing how people experience daily life. Emotion adaptive elevator lighting. In high-rise buildings, Mitsubishi Electric and related research groups have explored elevators that adjust lighting conditions based on detected passenger stress levels and crowd density. Using subtle sensors, the system modifies brightness, color temperature, and even transition speed to reduce anxiety during vertical transport. For example, a crowded elevator might shift towards softer, warmer tones, while a near-empty one maintains neutral lighting. The goal is not decoration, but emotional regulation in confined spaces. What makes this technology unusual is how it treats human psychology as part of infrastructure design. Elevators, often ignored as simple machines, become adaptive environments responding to emotional data in real time. Passengers rarely notice the adjustments consciously, yet they report feeling more comfortable. It raises an interesting idea. Emotional states can be engineered through environmental micro-adjustments that operate below the threshold of awareness. Smart shrine donation systems. In parts of Kyoto, traditional shrine donation practices are quietly evolving into digital systems that preserve cultural rituals while modernizing infrastructure. Instead of only coin offerings, visitors can use contactless kiosks that record anonymous donation patterns for maintenance and preservation planning. These systems do not replace spiritual tradition, but layer data analytics over it, allowing shrine operators to understand visitor flow, peak times, and seasonal patterns. What makes this technology unusual is the fusion of ancient ritual and modern tracking systems. The act of giving remains symbolic, yet it becomes measurable in ways previously impossible. Some critics see it as modernization of sacred space, while others view it as a necessary evolution for preservation. Either way, it reflects how even deeply traditional environments are being quietly integrated into digital ecosystems without altering their surface appearance. Robotic river cleaning swarms. In Osaka and other waterway cities, experimental robotic systems operate like coordinated biological swarms to clean rivers and canals. Instead of a single large machine, dozens of small autonomous units move together, detecting floating debris and distributing collection tasks among themselves. They communicate wirelessly, adjusting formation depending on current flow and pollution density. This swarm behavior allows them to cover large areas more efficiently than traditional cleanup vessels. What makes this technology fascinating is its mimicry of natural ecosystems, robots behaving like schools of fish or insect colonies. They require minimal human direction once deployed, continuously adapting to changing water conditions. The result is a self-organizing environmental maintenance system that feels almost alive. It suggests a future where pollution control is not a scheduled operation, but a continuous, autonomous ecological process. Sound shaping office rooms. NT developed acoustic environments are experimenting with directional sound control to reshape how offices handle noise. Instead of relying on walls or partitions, these systems use advanced audio wave manipulation to cancel or isolate sound zones within the same open space. Multiple meetings can occur simultaneously without auditory interference. Sound is precisely controlled so that speech is only audible within intended areas, while nearby zones remain silent or unaffected. What makes this technology unusual is its invisible architecture. Space is no longer defined by physical barriers, but by acoustic boundaries. It changes how people perceive shared environments, allowing density without chaos. The psychological effect is subtle but powerful. Workers feel both connected and isolated depending on their position. It transforms office design into a fluid experience shaped by sound rather than structure. AI-driven elderly mobility walkways. In Japan's aging population has led to experimental indoor walkway systems that assist elderly individuals with movement in subtle, adaptive ways. These walkways adjust speed, grip sensitivity, and surface responsiveness based on gait detection and balance stability. Sensors analyze how confidently a person is walking and respond instantly, offering micro adjustments that prevent falls without requiring visible assistance devices. What makes this technology remarkable is its gentle invisibility. It supports mobility without making users feel dependent. Instead of external support, the environment itself becomes supportive. It transforms architecture into a caregiving system. The psychological impact is significant, preserving dignity while enhancing safety. In essence, the ground beneath a person becomes intelligent, responsive, and protective in real time. Self-adjusting road asphalt. Experimental highway materials in Japan are being developed with heat-sensitive compounds that slightly expand or contract depending on seasonal temperature shifts. This reduces cracking and structural damage caused by extreme weather cycles. Unlike traditional asphalt repair systems, this approach is proactive rather than reactive, allowing roads to maintain smoother surfaces for longer periods. The material responds slowly and subtly, almost like biological tissue adapting to environmental stress. What makes this technology unusual is its self-regulating nature. Roads that behave like living systems rather than static infrastructure. It reduces maintenance costs and improves safety while requiring minimal human intervention. The idea of roads that adapt themselves challenges conventional engineering assumptions and points toward infrastructure that evolves continuously instead of deteriorating. Smart manhole monitoring networks. Across Japanese cities, manholes are being transformed into distributed sensor nodes that monitor underground conditions in real time. Equipped with vibration sensors, gas detectors, and water level monitors, these systems provide early warnings for earthquakes, flooding, and toxic leaks. Instead of being passive infrastructure points, manholes become part of a citywide nervous system. Data from thousands of points is aggregated to detect anomalies before they become disasters. What makes this technology unusual is its scale. Ordinary street elements becoming critical nodes in a predictive safety network. It turns invisible underground infrastructure into an active intelligence system. The result is a city that can sense danger from below the surface before humans are even aware of it. AI-powered train platform gap predictors. Japan's railway systems are experimenting with predictive AI designed to reduce platform accidents and improve passenger flow. Instead of simply monitoring gaps between trains and platforms, these systems forecast where passengers are likely to cluster and adjust train stopping positions accordingly. The goal is to minimize dangerous congestion zones and optimize boarding efficiency. What makes this technology unusual is its anticipatory nature. It doesn't react to movement, it predicts it seconds before it happens. Combined with high-resolution sensors, the system can dynamically influence train alignment in real time. This creates a smoother boarding experience while reducing risk in one of the world's busiest transit networks. It transforms train stations into predictive environments where safety is engineered through anticipation rather than correction. Autonomous last meter delivery pods. At the top of the list are Japan's experimental last meter delivery robots designed to complete the final stage of logistics in dense urban environments. While most delivery systems handle long distance transport, these compact robotic pods navigate narrow streets, station interiors, and pedestrian heavy zones to deliver packages directly from lockers or hubs to end users. They use advanced sensor fusion, mapping, and crowd-aware navigation to move safely through unpredictable environments. What makes them extraordinary is their role in solving the most difficult part of delivery, the final human interaction zone. They represent a shift toward fully autonomous urban logistics, where even the last step of delivery no longer requires human effort. In a city already optimized for efficiency, these pods hint at a future where physical errands may disappear entirely, replaced by silent, self-navigating systems moving constantly through everyday life. We've just walked through a version of the future that isn't arriving. It's already quietly operating beneath cities, inside hospitals, and even in the air between crowded streets. But the unsettling question remains: how much of your daily life is already being shaped by systems you've never noticed? And if these technologies are only the beginning, what comes next may not ask for permission at all.